Hello students, welcome back. In this video, we are going to discuss class 11th mathematics chapter 2, the relations and functions. Let's plunge into the video. Wait, before going to that, I request you to see my previous videos on sets. I have given a complete series on set theory, first chapter. I have given the introduction to all the exercises and solved all the exercises problems, including miscellaneous exercise. I have given an assignment also and important formulae at one place together. So go there and have a thorough understanding of the set theory. It will be useful in this chapter also. Let's start the study of relations and functions. See, relations means in our day-to-day life we come across many means real-time situations where two things or objects are related to each other. Say, for example, mother and son. Mother is one object and son is another object. The first object is related to second object. First object is mother of second. Similarly, suppose x and y. X is 10 more than y. That means what? X is related to y such that first object x is 10 more than y. X equals to y plus 10. Let's start the study of relations and functions in the next slide. Now, see, a relation involves a pair of objects in certain order. That is very important. You said just see, this is certain order because, as I said, first element and second element. In that first element is, see, in mother and son relation. Mother and son relation is what? Mother and son. First one is first. This is first element, right? This is second element. They are related with first element is mother of second element. If you take order is suppose S, the relation is what? This is the relation. First element is mother of second element. If you change the order, S M, first element is this relation doesn't hold good, right? First element is not mother of second element, relation doesn't hold good. So order, certain order is very important. Now, next is means what we are seeing is how to link pairs of objects from two sets. This is what we are discussing. How to link pairs of objects. How you link is with a relation. Introduce relations between the two objects. That is what we are doing. You need to have two pairs of objects, and we have to establish a relation between them. And finally, we learn how to learn about special relations which qualify to be a function. This is we'll discuss in detail in the next slides. But what we will discuss is first what is relations and I told you right. We will discuss what is relation. Now this is relation requires two sets of objects. So suppose I am giving an example. This is an example of two beverages, coffee and tea. This is this is set A. And the second one is different colored cups. You can say that is set B, which is having red color, blue color, and green color cups are there. These are these are cups. This is beverages. How many combinations you can have? C, C is and R. Also C and B. C and G. This coffee with all the three colors. And also now T. T with R, T in blue cup, T in green cup. So total how many are sets we can make? Totally six. Six number. That is how this is having two numbers, this is having three. So this product is six. So totally six pairs we can make. Precisely, this is called the Cartesian product. Product. Cartesian product of the two sets. Number of elements in the first set and number of elements in the second set. The product of them give you number of pairs. Okay, I will define in the next slide what is a Cartesian product. make a definition. See, the definition goes like this. Given two non-empty sets, P and Q should be non-empty. Then the Cartesian product is the set of all ordered pairs. This is important. Ordered pairs, and the elements from P and Q, that is P in cross Q. P into Q equals to PQ, such that P belongs to P and Q belongs to capital Q. This is the definition. So next, I will give you another example. See, we are making some license plates for the different states. The states are Delhi, this is Delhi, and Madhya Pradesh and Andhra Pradesh, like that. And the license plate codes are, you can say, 01, 02, 03. You have to make license plates using these two objects. The first set is, suppose this is A, and second set is this name of the states. This is license plate codes. See, we have to make license plate pairs. You have to make pairs, and the condition is first element should be element from the set A. That means you have to take DE 01, DE 01. Second one is DE 02. Third one is DE 03, like this. Similarly, we'll have for AP, for Maharashtra 01 and AP 01. So total will be how many? 3 into 3. This 3, total 9. This is the Cartesian product. So 9 objects, 9 pairs can be made from these two sets. Also note that order order is crucial, very important. Why? Because DE01 is not same as 01DE. Have you seen any odd such type of number plate anywhere? License code? No. So this is very important. First element should be always in the list of the ordered pair, right? So we'll make some notes here. Two ordered pairs are equal if and only if and only if the corresponding first elements are equal and the second elements are also equal. Okay, that means ordered pairs are, suppose A1 and A2 is there. If A2 and A1 is there, this is not equal to this. The set is, this is not equal to this. That means the second one, if there are P elements and in A and Q elements in B, then there will be PQ elements in A into B, A cross B. This is a Cartesian product. That means you can see N A cross B equals to N A, number of elements of A, into number of elements of B. This is an obvious and important relation. Okay, that is nothing but that is P into Q. When NA is P and NB is Q, the number of elements of A cross B, A Cartesian product of A into B is PQ. And also N and B are non-empty sets, and either A or B is an infinite set. There is, then so is A and B. That means AB is also, A cross B is also an infinite set. Infinite set. A cross B is also, A cross B also an infinite. Now comes A triple product A A into A. It's not a pair. It is a triplet. This is called a triplet. It's an ordered triplet. So let A equals to 1, comma 2. So A cross A cross A is what? I will show you. 1 and 2. This is, yeah. Here you can write. See, suppose we will take this is 1, comma 2 into 1, comma 2 into 1, comma 2. First we'll take 1, 1 and 1. So this is first element 1, comma 1, comma 1. Next what? 1, 1, 2. 1, 1, 2. This is next 1, 2, 1. 1, 2, 1. Next is what? Similarly, we will take 2. 1, 2, 1. Next what? 1, 2, 2. Correct? 1, 2, 2. This is how you'll keep on taking the elements. It's an elaborate process. But what I wanted to tell you is it is an ordered triplet. It's not ordered pair because we are dealing with three sets, we'll get triplet. If we are dealing with two sets, we'll get a pair. That's the point I wanted to stress. So ordered pair is very important. Again, I want to reiterate. Suppose a number plate is there. D and suppose Delhi number plate is there. D01. This is first element and this is second element. This is normally we accept this. If it is taken 01 and D, we had reverse the order. Is it valid? This is not the way we give number plates. This is a practical example where you can see ordered pair, importance of the ordered pair. This ordered pair. See, the importance of the ordered pair. This is important. Okay. Next, we'll move to the, now we'll see what is the notation of the relation. Also note that one of the sets is infinite, then A cross B becomes infinite. Suppose any number x into infinity becomes infinity, right? Similar to that. Second one is also one more thing I wanted to add, A cross phi. If one of the set is null set, that becomes a null set. Suppose any number x into 0 becomes what? 0, right? Similar to that. It is also to be noted. In this, suppose number of elements are, suppose here 2 and here 2. Then it is 2 into times. You can say 2 times and gives you 8. 8 elements will be there. See, third dimension you can say. So 8 elements will be there. So see, first example we'll see. This is if x plus 1, y minus 2 equals to 3 comma 1. This is a pair x plus 1 and y minus 2 and 3 comma 1. This is find the values of x and y. This is equal to this means this is an ordered pair. Ordered pair means first element equals to the first element of the first set equals to the first element of second set. This x plus 1 equals to 3. Y minus 2 equal second element is y minus 2. That is equal to 1. So solving this, you will get the results. Elements are in pairs within normal brackets. These are the pairs of the elements. And ordered pair is first element of the first set equals to first element of the second set. Second element of the second set is equals to second element of the second set. This is what I wanted to stress. Okay. Now this is if P is equal to A comma B comma C. This is one set. These are the three elements. This is another set with one element. Sets P and Q. What is Cartesian product of P and Q? If P and Q is what? A, R, B, R, and C, R. Correct? First one. P, Q. And what is Q and P? R, A, R, B, and R, C. Right? This is the one. Just check whether P and Q are equal to Q and P. See, A in R is not equal to R and A because order is important. Let us see this example. A is 1, 2, 3 and B is 3, 4 and C is 4, 5, 6. Find A cross B intersection C. Now what is B intersection C? B intersection C is 3, 4 and 4, 5, 6. What is common in these two elements? Two sets. 3, 4, 4, 5, 6. 4 is only element which is common. So the given thing is A cross B intersection C is 1, 2, 3 multiply. This is a product, Cartesian product. 4. Okay. This is the what we have to find out. So Cartesian product is how many elements are there here? In this 3 are there. Here one element is there. 3 into 1 is what? 3. 3 elements will be there. 3 elements. This is for your rough estimation. So 1 comma 4, 2 comma 4, 3 comma 4. These are the elements in this Cartesian product. Right? We will see this another example. A cross B intersection A cross C. Find out A cross C first. What is A cross B? A cross C means what? 1, 2, 3 cross B is what? 3, comma 4. By this time, you should know how many elements we are getting in the product. 3 into 2, 6 elements you should get. I will write down the pairs. 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. So these are all the elements. We'll get 3 plus 3, 6 elements we are getting. This is the cross product of A and B. What is A into C? What is the Cartesian product of A and C? This is what? This you will get 1, 2, 3. You will get big number here. Cartesian product of 3 into 3. 4, 5, 6. You will get. I'm just doing it. It's a laborious process, but just you will when if you do this, you'll get complete understanding of the this is Cartesian product, this is ordered pair, this is how you will these doubts will be clear. Okay. 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6. Similarly, 3, 4, 3, 5, 3, 6. Right? These are all the pairs. This is the Cartesian product of it. Now intersection A cross B and A cross C. The intersection of it is what? What are the common elements in that? 1, 3 means 1, 2, 3 is 1, 4. Anywhere is there? 1, 5. You see, now 1, 4. We just take these 3. 1, 3, 1, 3 is not here. See, here you can easily see this 3, 4. 4 is common here in B and cross B and A cross C, right? 4 is common in B and C. So naturally, around that elements will be common. Let us see 1, 4. The 1, 4 is common here. 1, 4 is common. Then 2, 4 is there. Yes, 2, 4 is there. Next, 3, 4 is there. And no other elements are common because 5 and 6 are not there in this first set. So there's no other elements are common. This is the intersection of these two Cartesian products. Next one is we see a three set triple product. This means P into P into P. P is a set of 2 elements, 2 comma 3. Then now Cartesian 3 means product of P and P and P. So how do you write this? This you can write like this. Means here, see, this is 2 comma 3, 2 comma 3, 2 comma 3 cross. How many elements will be there? 2 into 2 into 2, right? This is what we have seen in the formula. These 8 elements will be there. You can get a rough idea. Now, how do you write this? 2, 2, and 2. All the first two elements. Start with 2, you will get first triplet. This is a triplet. Remember that. 2, 2, 2. Next 2, next 2, 3, 2. That means you have to take the first element, first element, first element. Then first element, second element of the second set, and first element of the second set. Then 2, 3, and 3. This 2, 2, 2 and 2 will take, will write like this, 2, 2 and 2, right? This is first element, then 2, 2 and 3. I will put the commas at the end. 2, 3, 2, 2, 3, 3. This is how you take the triplets. And next second element, I will take 3, 2, 2, 3, 2, 3, 3, 3, 2, 3, 3, 3. These are all the, so 8 elements have come. That is a complete list of the triplets which we are getting A cross A plus A in, P into P into P. Okay, this is the solution. Just to have an idea of a multiple Cartesian product in triple product. Just say again. I have given this examples. We'll see the next example is a little more interesting. Yeah. Next one is if R is the set of all real numbers. What do the Cartesian product R into R and R into R into R represent? This is interesting. Why I said interesting is because you can see in the coordinate geometry, you will be learning this two-dimensional. See, it represents graph, two-dimensional representation. And if you want this R in the third dimension also, if it R into R into R is there, you can have a Z-axis. This is Z-axis. This is 1, 2, 3. This is -1, -2, -3. This is how it is represented. It is three-dimensional. So this R and R represents the x, y, z belongs to R, which represents the coordinates of all points in the three-dimensional space. That's what I wanted to show you. This is three-dimensional space. Suppose this is a cube, this is a cuboid, right? All these points, this from here to here, this is 1, and this is, suppose this is 1. This height is 1. This is, the depth is also 1. This is three-dimensional figure. The dimensions are 1, 1, 1. I have taken this is how all the real numbers R into R into R will represent in three-dimensional space. This is pair. Remember that is pair, and this is triplet. Okay. Now we'll start exercise 2.1. The first question is if x plus 1 y minus 2 by 3 equals to y by 3 comma 1 by 3. Find the values of x and y. These two are ordered pairs. They are, this pair is within the brackets. These two values are a pair. These two, first element is x plus 1, second element is by minus 2 by 3. This is equal to another ordered pair. D. When two ordered pairs are equal, then we have seen that in the introduction, first element of this pair should be equal to the first element of the second pair. Second element of this pair is equal to the second element of the second pair. By that, we can solve the x and y easily. So these two are ordered pairs. So in the ordered pairs, the first element of the first pair should be equal to the first element of the second pair. Similarly, second element of the first pair it should be equal to the second element of the second pair. So we'll equate them. This x by 3 plus 1 equals to 5 by 3 and y minus 2 by 3 equals to the 1 by 3. Y minus 2 by 3 equals to 1 by 3. On solving, we get x equals to 2 and y equals to 1. It's a simple solution. I will show it. The x plus 3, I solved it here for you. X plus 3 by 3 equals to 5 by 3 and x plus 3 equals to 5 and x equals to 2. The denominator. Y equals to 2 by 3 plus 1 by 3. Take this 2 by 3 the other side. You will get 1. 2 by 3 plus 1 by 3 equals to 1. So that is the solution. We'll move to the next question. Pretty easy, right? You should understand the difference between ordered pair and here we are dealing the sets. We are dealing the sets. In that sets, ordered pairs are there as elements. Ordered pairs means in the normal brackets, round brackets, there will be two elements there as a pair. They are ordered pair. That is as element in the set. Two sets are related with some relation. I will tell you the relation in the next video. But this is now you just remember just understand that these ordered pairs are the elements of the sets. We'll move to the next question. Now the second question is if the set A has three elements and set B has 3, 4, 5 as elements, then find the number of elements in A cross B. Now we'll see in the Cartesian product. We have to this is the Cartesian product. A cross B is the Cartesian product. In that only we'll get the ordered pairs. Here you will get the ordered pairs. I will show you. See here you can say number of elements of set is 3, right? And number of elements in set B is how many? Also 3, correct? So find the number of elements in the Cartesian product N A cross B. We have seen the introduction. What is this? Na into Nb. This is the formula we have seen. This number of elements in the Cartesian product, this is the Cartesian product, is number of elements of individual set A, individual set B. Okay. So what is this is set A. This is having 3 elements. This is having some elements A1, A2, A3, and this is another set 3, 4, 5. Here, two sets are making an ordered pair. We'll go with each and every element. Similarly, A2 will also go to all the 3, 4 elements. Like that, we'll get how many products, Cartesian products will get Na into N3. This is number is 3. This is NB is 3. So how many elements will there? 9 elements will be there in this Cartesian product of A and B sets. These elements are what? Ordered pairs. Remember that I am repeating it again. Ordered. They are the ordered pairs. See what are they? You can say A1, 3. This is order is very important. From this is set A, this is set B. Right? Ordered pair is first pair is A1, 3. Second pair is A1, 3, A1, 4. Third, this is A1, 5. Like that you will get with A2 also same thing, A3 also will 3, 4, 5 will be. We'll get 9 in total, 9 elements will get. These are all the order pairs and you will have this complete is a set. What is that set? A cross B. In that 9 elements are there. This is the fundamentals. This is the principle of this. So now A, see what is asking? A is 3 elements and set B. Find the number of elements in A cross B. This is the answer. Simple, right? This is pretty straightforward. We'll move to the next question. Now, see, here he has given two sets, G and H. This is having two elements. This is having three elements. Find the Cartesian product V into H. The, gives you how many. Find what is. See what is that? I will write down the that 7 comma 8 into 5 4 2. You can write each and every element like this. 7 will go with pair with all the three elements. Each and every element 7 comma 5. This is how you write the first element, comma 7 comma 4, right? Comma 7 comma 2. Next is 8. We'll do 8. 8 comma 5, 8 comma 4, 8 and 2. These are the elements in this. The number is also see two elements into three elements. 2 into 3 means how many elements will be there? Six elements there in the product. So here we are getting six elements. So that's verified. And now what is H and G? H, Cartesian product of H into G. What we have to do? We have to take H first. Cross 5, 4, 2, 7, 8. This is what this is. We have to see with 5, we take all the other two pairs. 5, 7, 5, 8, 4, 7, 4, 8, 2, 7, 2, 8. This is the list of all the elements. Did you observe that the pair is 7, 5? The second pair here in the first pair of the second, this H and G is 5, 7. They are not the same. A, B, this is one ordered pair, and B, comma, these are not equal to each other. Remember that. This is very important. This is very important. So this is the H and G. This is G into H. This is H into G. Here, this you can clearly observe V cross V into H is not equal to H into G, right? H into G. Also, number of elements. You can see V into H is equals to H into G because 2 into 3 is equals to 3 into 2. So I think you understood this. We'll move to the next question. See, in this question, he is asking whether given statements are true or false. He has given three statements, and if they are false, rewrite the given statement correctly. We have to mention them whether it's true or false. First thing is, see, first one. So P is this one. First one is clearly false. So how can you say that false? Because this is P into Q. How many elements will be there in that P into Q? This is having two elements. This is having two elements. So 2 into 2, 4, 4 elements should be there. But here you have got only two elements, Mn and Nm. These are two ordered pair. These two ordered, this is one ordered pair, this is another ordered pair. This is one element and this is another element. Only two elements there, which is, so this statement is false. So correct this. P into Q equals to what? M comma N into N comma M. You simply write the cross Cartesian product. This is Cartesian product M, Mn and MM and N, 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 M. So four elements will be there, four ordered pairs within that. This is the same. This is the this is P Cartesian product of P and Q. Second one, if A and B are non-empty sets, see non-empty sets. That means some elements are there in the sets. Then A cross B is a non-empty set of ordered pairs X and Y, ordered pairs X and Y, such that X belongs to A and Y belongs to Y. This is clearly true. This is the definition of the A cross B. Definition. It's the definition of A cross B. Okay. Definition of A cross B. A cross B is X, comma Y such that X belongs to A and X, Y belongs to B. This is the by definition it is there. We'll get the ordered pair X and Y. This is how you define the Cartesian product of two sets, right? If you are having two sets, you will have an ordered pair. If you have three sets, what you will get? You will get an ordered plate, ordered pair, and ordered triplet. A into B gives A into B into C gives you ordered triplet. This you remember. Next, the third one. What is third one? A is 1.2, 1 comma 2. A is 1 comma 2. B is 3 and 4. Then A, B intersection B. B intersection 5 is what? 3, B intersection 5. You can clearly say that anything B, any set intersection 5 is 5. You don't need to write anything. You are now, I think you are experts in that set theory. You go through all my videos in the set theory. I have elaborately explained everything and I have given all the necessary concepts and all the formulae at one place. In the last video, you can see that. All the formulae at one place. In nutshell, you can go and see them and okay, at a glance, you can see all the formulae and all the concept in one place. You will have, you can skim through that and get all the grasp of the set theory. Okay. So this is so ordered pair is this. So now what is you wanted? A cross B intersection phi is what? A Cartesian product of into phi. The very definition says that two non-empty sets, then A cross B is defined. If an empty set is there, it becomes phi. The product becomes phi because it's similar to you multiply a number 4 into 0, it is 0, right? It's like so this ordered pair also with a null set it becomes null set. No pair is there formed. This is that. We'll move to the next question. Yeah. Now we are seeing the ordered triple product. See what he wanted is A into A into A. This is you will get an ordered triplet ordered triplet, right? Remember this. We always, when two sets are there, we'll get a pair, ordered pair. When three sets are there, you will get ordered triplet. So what is A cross into A equals to? This is minus 1, comma 1 into minus 1, comma 1 into minus 1, comma 1. There are two ways of doing this. And it's actually it's one way only. You can take these two first and take the Cartesian product with the third one. That will be simpler when compared to if you keep writing minus 1 and then pairing with each and every other element, it will be difficult. So what I'll write is, we can do like that. A cross A is what? Minus 1, 1. You will not be lost if you do like that. It's laborious. You can do directly, you can do, or this is a simpler way. That's what I understood. Minus 1, you write minus 1. This pair minus 1 to minus 1, right? Minus 1 to minus 1 and minus 1, 1. 1 minus 1. 1, 1 and 1. This is A cross A. Now what is now again this multiply A cross into A cross A equals to, now this we can, this one. So as you see, this is an ordered triplet. A into A into A gives you 3 triplet. It results in 3 triplets because 3 sets are involved in that. So this is minus 1, comma 1 into minus 1, 1 and minus 1 into minus 1, comma 1. This is the thing. And A into A will do it can be, it is easier to take first two cross product first and then multiply the result with the third one. A into A is minus 1, 1 into minus 1, 1. This, this results in this first minus 1 element is taken, the remaining two minus 1 with the first pair, and minus 1, this 1 plus 1 is the second pair. And then again, this second element will take 1 minus 1, 1 pairs with the remaining two elements, 1 minus 1 and 1 plus 1. This gives you the, this is A into A. Now this we are multiplying again with the third A. Third A is again minus 1 in comma 1. So this first element will pair with the each of these two elements. Minus 1 pairs with minus 1 first. Minus 1 pairs with the second one, 1. Okay, you got it? This is the one. So third, second one, minus 1, 1 pairs with minus 1. Minus 1, 1, minus 1. And minus 1, 1 pairs with 1. Minus 1 pairs with 1. Similar like that, you will you all the write all the elements, you will get total 8 elements. Because 2 into 2 into 2, each set is having 2 elements. So number of elements should be 2 into 2 into 2, 8 elements are there. Nj is 2. So how many are there? N A cross A cross A is Nj Nj into Nj, right? 2 into 2 into 2, which is 8 elements, right? So that's it. We'll move to the next question. Now, in the sixth question, see this. A cross B equals to, he's giving he's giving the elements. A cross B is not giving the elements in individual, but he's giving the ordered pairs inside the A cross B Cartesian product. This is the pair. First element, first pair is A comma X, A comma Y, B comma X, B comma Y. Find A and B. What is the elements of B, A and B? This is what he's asking. A cross B means what? This is what? A comma X. This is first element, right? And this is second element. This is the order pair. So first element is from the first set. Second element is from the in the pair. Second element is from the second set, right? This is what we do. Second set. So first set A is this. So what are these elements of the first set? This one A, and this is A is in the first elements are all first belongs to first set. These are all belongs to first set. So A is there. A is already A is we can is already we written, so we will not write again. B and B is written, so we will not make it again. So these are the two elements. And B is what? Second elements. All the second elements. What are the second element is X, X, Y, Y. Second element is X and here Y. And X we are already written and Y also written here. So we'll write once. These are the two A and B sets. Simple, right? First element we have to write, first elements belong to the first set. Second elements belong to the second set in the ordered pair. That's the concept. If you understand that, this is very simple. So we move to the next question, that is 7. Let A equals to 1 comma 2 and B is 1 2 3 4, C 5 6 and D is 5 6 7 8. You can observe this. These A and B are having two common elements and C and D are having two common elements. Just for your notice, I am giving this. Verify that this A cross B intersection C equals to A cross B intersection A cross C. Let us first find out what is B intersection C. What is B intersection C? B is this and C is this. Any elements are common in this? B intersection C is null set. Clear, right? So A intersection null set. You are all experts on sets now. What is this? This is null set. Any set intersection of null set is, they don't have any common. Null set is having no element, so it doesn't have any common element. So this is the first one. This is, you can say, LHS. LHS is 5. What is RHS? You can write, say, what is A cross B? We'll see, but A cross B is what? A cross B. It's a big thing. I give you a, an insight into this. 1, 2, 1, 2 is there. We will frame some items. 2 into 4, 8 elements can be found with this, but they will have 1, 2 in this, and you want 3, 4. 1, 2, and 3, 4. This all will be formed with 1, 2, and 3, 4. What is C cross D? It will have 5, 6, 5, 6, 7, 8. So it will be having elements with 5 and 6. Correct? No? 5, 5, 5, 6. It goes on like that. But no element 1, 2 will not be there. Here 1, 1, 1, and 2. It goes on like this, right? But no element will be, no 5, 6 will be there. So on observing this, of course, you have to do everything. You have to write all the elements and then only you prove that. So clearly, A cross B has no common element in this. It starts with only 5 and 6 and the elements are there. Here 1, 2, 3, 4 elements will be there. A cross B and intersection C cross D is 5. These elements, writing this is your homework. You write out all these elements, you will get practice. With this, all these elements, you will you will find, definitely will find that there are no elements which are common to that. Now, second one, what is A and C is a subset of B and D? Verify is asking us to verify. A and C is A cross C is a subset of B cross C. What is A cross C? What is A cross C? A is 1 comma 2 cross C is 5 comma 6, right? How many elements will be there? Yes, you are right. 4 elements will be there. Write down 1, 5, 1, 6, 2, 5, and 2, 6. These are the 4 elements you have, right? So what is B into D? How many elements will be there here? B is having 4, D is having 3. 4 is, D is having 4. So how many elements will be there? Just you tell me. 4 into 4. 16 elements will be there. You have to write 16 pairs here, ordered pairs. Remember that. Okay. So 1, 2, 3, 4, cross 5, 6, 7, 8. I'm leaving out the commas. Okay. Equals to first 1, 5. Right. Next 1, 6, 1, 7, 1, 8. And that's a part of the first. Second one is 2, 5, 2, 6, 2, 7, 2, 8. Everywhere put commas. Okay. Second, third one, 3. With 3 you will have 5, 3, 6, 3, 7, 3, 8. Similarly, you will have 4, 5, 4, 6, 4, 7, 4, 8. Now see, you can, in the sea of all these elements, you have to find out which is common. One thing is, you can see here, if you are smart enough, you can see 5, 6 are there here and 5, 6 here. These are the two elements which are common to both the sets. So we can easily grasp 1, 5. You just search for the 5 and 6 only. 1, 5 is there, 1, 5 is there. 1, 6 is there, 1, 6 is there. This one is there, this 2 is there, this one is also there, 1, 6, 1, 6, 2, 5. Wherever 5 is there, you just for 1 and 2 combination. 2 5 is there, 2 6 is there. Okay, these are that. Nothing else will be common because other elements 3 4 will not be here in this. This is no 3 4. Here there is no 3 4. 7 8 is not there. So all these elements will not be part of this thing. A cross E is definitely these are the elements. Definitely this is A cross E is a subset of B cross D. Therefore, A cross C is a subset of B cross C. Right? This is what I want to prove it. Okay, this is definitely a subset of B cross D. Is a subset of B cross D. We'll move to the next question. Now we move to the eighth question. Here, two sets are given: A 1.1 comma 2, B 3 comma 4. Write the A cross B. How many subset will be A cross B have? And list them. A equals to 1 comma 2 and B is 3 comma 4. So what are the A cross Cartesian product? What is A cross B? 1 2 comma into 3 4. Right? The Cartesian product is 1. You take 1 pairs with the other 3 elements, other 2 elements, sorry. 1 3, 1 4, and 2 pairs with the other 2 elements. 2 2 3, 2 4. That's it. This is very simple, right? But the problem is now you have to, it's not a problem, but the thing is you have to find out how many subsets are there. This is also easy, but list them. That is very laborious. Then how many subsets are there for this? How many elements are here? 4. So what are the number of subsets? Tell me. 2 raised to n is the number of subsets. It is number of subsets, correct? Of set NA. That means n number of elements are A, n are there, then is 2 raised to n is the number of elements of the number of subsets, possible subsets. 2 raised to n means here 2 raised to 4 is how much? 2 raised to 4 means how much? So this is so many will be there, subsets will be there. So we have to start listing them. I will start listing them. We need some space for that. First subset is what? Yes, you guessed it right. First subset is, don't write. First subset is 5. Second one is 1 3. We can keep writing all the 1 4. Each and element you can write 2 or 3. I'm writing them in this thing like this. Okay. Put them in brackets. Put them in brackets. Curly brackets. All this should be in curly brackets. I'm sorry. Curly brackets. 2 3 and 2 comma 4. These are all the ordered pairs. This is, you can put them as ordered pairs. Curly brackets and round brackets both should be there because this is the element. This is an ordered pair is the element inside the curly brackets. Okay, this is set outside. This is set, and this is the element 2 comma 4 within normal brackets is the element here. Don't leave them. Otherwise, it becomes 2 is an element and 4 is an element. No, it is the brackets within brackets. This normal brackets. This is the element. Right. First, this how many? This is 5, right? Totally, how many 5 elements are there? We have to write 16 elements like this. Next is what? We'll take 1 3, 2 2 each. We have taken individually every ordered pair. Each element you have taken it. 1 3, 1 4. 1 3, 1 4. And 1 3, 2 3. 1 3, 2 3. Okay. Next 1 3, 2 4. Right? This how you have to write. How many? 1, 2, 3. 3 we have written. I'm going to write one more. Yes, 2, 3. Next one is what? 1, 3, 1, 4. 1, 3, 1, 4 is there. 1, 4 with 2, 3. These two elements together, one set. 1, 4, 2, 4. 1, 4, 2, 3. With these three sets, we have to 1, 4, 1, 3, with 1, 4, 2, 3, 2, 4. 1, 4, 1, 3. With 1, 3, you get 1, 4, 2, 3, and 2, 4. And with 1, 4, we will have 2, 3, and 2, 4. Right? This is another set. How many sets are there? 1, 2, 3, 4, 5. Here another 5 are there. So next is 1, 4 is over 2, 3. With 2, 3, 2, 3, you will have 2, 4. Right? So that's it. If the two elements will have this many. This 5 plus 6, 6 will be there. And next, this is 1. Next is with three elements we have to write. Three sets. 1, 3 will pair with 1, 4 and 2, 3. This is one set. 1, 3 also pairs with 1, 4 and 2, 4. Right? And 1, 3, 2, 3, 2, 4. This is one set. Next is 1, 3, 2, 3, 2, 4. This is 1, 2, 3. 1, 3, 2, 3, 2, 4. So next one is you have to make this 1, 4. See, 1, 4 will make pair with other two. 2, 3 and 2, 4. Which is the triplet. Which is three elements set. Okay, this three. Now rest if you take 2, 3, it will be repeated. 2, 3, 2, 4, 1, 3, 2, 3, 2, 4. 2, 4, 2, 3, 2, 4, 1, 3 will be repeated. Others will be repeated. That ends the cycle there. Last one is take the set itself. All the set complete set itself. All the elements. You take 1, 3, 1, 3, 1, 4, 2, 3, 2, 4. There ends this thing. So this is the game. So how many are there here? 1, 2, 3, and 4. Here 4 elements are 4 there, right? In this row 4 are there. And this is 1. Total is 16. So we got 16 subsets. This is the list of all the subsets. I think you understood this. I have taken the pains to write this, and you also take practicing it on your own, write down. Okay. Next, we'll move to the ninth question. See, next question. In this, A and B two sets. NA is given 3 and NB is given as 2. That means number of elements in this set is 3. Number of elements in this set are 2. And he is also giving the elements in the A cross B. These elements are there. Some elements are there. X, comma 1, Y, comma 2, Z, comma 1. These are the elements is given. Find A and B. What are the elements in that? See, you can see A is the first element belongs to all these first elements belong to the first set. So, how many elements are there in the first set? 3. So, A you can write what's the first element? X, also Y and Z. And this is X, Y, Z are the elements. Total elements we got 3. Number of 3 elements are there. We got 3. This is the set A. What about B? How many elements are there in B? B is having 2 elements, right? So what are they? The second element in the ordered pair belongs to the second set, right? What is the second element? 1, 2. Also, 1 is repeated again. We don't need to write. Only 2 elements are in the second set. So 1 comma 2 is the set elements of B set B. Pretty easy, right? It's only bit common sense. First, this first elements of the pair belongs to the first set, second element belongs to the second set. That is the concept. So I think it is clear. We'll move to the last question of this exercise. Here in the 10th question, Cartesian product of A and into A has 9 elements. That means it is multiplying to itself. It is multiplying with itself. It is having 9 elements, among which minus 1 comma 0 and 0 comma 1 are elements. Now find the set A. What is given is n A cross A equals to 9. So n A cross A is what? N A into n A, right? Equals to 9. So n A equals to 3. So in each set you have 3 elements. So what is the elements which are given? Minus 1, 0. So A equals to minus 1, 0, 0, comma 1. These are the two ordered pairs they have given. This first A element belongs to set A. So we can write safely minus 1. And also this first element belongs to the set A, 0. Next, second element also belongs to set A because the set A itself is multiplying to A. It is also 0 we have already written. So second element is 1. So 1. 1 is the also belongs to set A because second element also belongs to set A because it is set A is multiplying to itself. First set is A and second set also is A. So the second set element is also the second element is 1. So these are the three elements which are present in this set A. So set A, we have seen that set A has got only three elements, right? So we found all three elements. This is the solution for this. That concludes this exercise, and hope you understood the exercise well. Have practiced all these things and go through the introduction completely thoroughly. You can solve the problems very easily. We'll go to the other concepts in the next videos, that is relations and functions. Before that, like and subscribe my channel and also share with your classmates and friends. Thank you.